Good day to all. Welcome to the fourth part of the tutorial section on electrostatics in Unit 1. So today we are going to see about a problem where the four concentrated charges are located at the vertices of a plane rectangle shown. Find the magnitude and the direction of resultant force on Q1. So the charges are placed in the corners, that is vertices of a plane rectangle. So four charges are placed and the place values also given. So Q1 charge have 0.2 microcoulomb and Q2 have 0.1 microcoulomb and Q3 and Q4 are having minus 0.2 0.1 microcoulombs. We have to find out the force on this particular Q1 charge due to the charges Q2, Q3 and Q4. So in order to find out the force, we can segregate the forces as first one between the force between Q1 and Q2, which is F21. The force between Q1 and Q3 is F31 and force between Q1 and Q4 is F41. So the directional vectors are also given in the figure. You can notice this particular charge is positive charge and this is also positive charge, so repelling force will be there. So repelling force has been drawn like this, and you can see between Q1 and Q4 both are positive charges, so repelling force will be acting. And also between Q1 and Q3 the both charges are negating in nature, so one is positive and another one is negative. So attractive force will be acting. So in order to find out the force between these charges, we are going to find the distance between these all the charges. So in the problem itself, they get given the distances. This is 5 centimeter, this is 2 centimeter, but we don't know what is the length between this Q1 and Q4. So in order to find out the distance between Q1 and Q4, we will be making the parallelogram law, which is equal to root of 5 square plus root of 2 square, which is 5.38, which is the distance between the first charge and the fourth charge. So in order to find out the components of the forces acting on the Q1, F21 can be Q1 Q2 divided by 4 pi epsilon naught R square AR cap. We can also write this equation as Q1 Q2 divided by 4 pi epsilon naught R21 vector divided by R21 whole cube. So to find out the value of R21, we can subtract these 2 points. So 5 minus 0 is 5 I vector, because this is on the x-axis, so it is I vector. 2 minus 2 is 0, so we will be having 0 j vector, so R21 is going to be 5 I vector. So what is Q1? Q1 is 0.2 into 10 to the minus 6 into 0.1, Q2 is 0.1, so 0.1 into 10 to the minus 6 into 1 divided by 4 pi epsilon naught value is 9 into 10 power 9, this we already know, into 5 into I vector divided by 4 R21, so the magnitude of this R21 is 5, so R21 whole cube, so 5 power 3 into 10 power minus 4. Here you can cut this 5 and 1 5 here, so 5 square will be the remaining part, and if you substitute if you calculate these values, then our answer is going to be 0.0072 into 10 power minus 3. But here the 10 power minus 4 is available here. Why we have written 10 power minus 4 is we are having the centimeter as the distance between Q1 and Q2, and all the distances are given in centimeter. So in order to find out the value of the centimeter, we will be going to substitute the value of 10 power minus 4 in the denominator, and if it is going to be the upper one, then the answer will be 10 will be the resultant of this 10 power minus 3 and 10 power plus 4. So if that is going to be multiplied with this answer, then the final answer is 0.072 I vector Newton. Okay, so if you want to find out if only the magnitude of the force, that is 0.072 Newton, or we can say the direction 0.072 I vector. Next we have to find out what is the force between the 3 and 1. So Q1 Q3 divided by 4 pi epsilon naught R cube R31. So this particular thing is R31, magnitude of the distance. So Q1 is minus 0.2 into 10 power minus 6. Q3 is minus 0.2 into 10 power minus 6. 1 divided by 4 pi epsilon naught is 9 into 10 power 9 into the R31. So what is the R31? We are going to subtract this from this. So we will be having minus 2 j vector will plus 2 j vector will be the answer for the R31. So 2 j vector divided by 2 power 3 into 10 power minus 4. So if you cut this 2 and another 2, so here 2 square will be there, here another 10 power minus 2 is there. So how this 10 power minus 2 will be coming? So in order to compensate this particular centimeter value into the meter value, we are going to multiply it with the 10 power minus 2. Here also, why 10 power minus 4 has come? Because 2 and 2 has been cancelled, so here only square term is there. So 10 power minus 2. So in order to change the centimeter into meter, we will be having 10 power minus 2 is the so 1 meter is equal to 1 centimeter is equal to 10 power minus 2 meter. So in order to change the centimeter into meter, here also we have to change. So 10 power minus 2 has been multiplied, but here since this particular term is cube, but it has been cutted here as 2 power 2, because 2 power 3 has been become 2 power 2. So this 10 power minus 2 power 2 means we can write this as a 10 power minus 4. That's why the term has came. Here also this for the same reason only, here also the 10 power minus 4 is came. So if you just reduce the particular equation, then we will be getting answer is minus 0.9 j vector, or if you want to find out in the magnitude format, then minus 0.9 will be the answer for force between Q1 and Q3. Similarly, we can find out the force between 1 and 4. So Q1 Q4 divided by 4 pi epsilon naught R41 cube into vector R41. So what is the vector R41? So R41 vector is going to be with the subtraction between 5 comma 0 to the 0 comma 2. So 5 minus 0 plus 5 minus 0. So 5 I vector 0 minus 2 minus 2 j vector. So this is going to be your R41 vector. So this R41 vector has been utilized here. So Q1 is 0.2 into 10 power minus 6, Q4 is 0.1 into 10 power minus 6, 1 divided by 4 pi epsilon naught is 9 into 10 power 9 divided by this particular thing. So if you just calculate this value, then it is already calculated as 5.38. So 5.38 cube into 10 power minus 4 into 5i vector minus 2j vector. So if you reduce, the answer will be 0.0578 I vector minus 0.02312 j vector. So if you add these all values, then the answer will be this. And also if you find out the magnitude of this particular vector, then the answer will be 0.88